Okay, today what we're going to talk about is we're going to talk about purifying an organic compound using column chromatography. Specifically, this is flash column chromatography as distinguished with gravity chromatography. Flash chromatography is faster and also has an increase in efficiency. So when you're getting ready to do a chromatography, it's really important to prepare completely. There are a few things that you need to know before you even get set up for chromatography. The first is you need to decide the polarity of your mobile phase. So when picking a polarity of a mobile phase is you want to use TLC to find a solvent that gives you an RF of between 0.1 and 0.2 on the TLC plate. That solvent will be ideal for separating a compound that has that retention. So you start with TLC and then you move into column chromatography. So the first thing I'm going to do now, and I'm going to stop talking because there's already a video about TLC. The first thing I'm going to do now is take a sample of our crude material here, and I'm going to run TLC on that material to figure out TLC conditions that are ideal for column chromatography. So I'm going to stop talking and I'll accelerate this part of the video. If you want to know how to run TLC, see the video on TLC. Okay, so we're back, and I've just completed a TLC, and the first thing that you need to do is find a TLC solvent that runs the compound of interest at an RF of about 0.2, and I'm going to hold this up to the camera so you can see. For this particular compound, when you have a 1% ethyl acetate in 99% hexane solution, you get an RF that's very close to 0.2. So that was my first test. So now I know that that solvent that got this TLC with the spot close to the bottom, close to the origin, only moving about 10% to 20% of the distance, that solvent is ideal to do a chromatography column in order to purify a material that has that polarity. So now I know that's what I'm going to load onto my column. So the next thing we need to do, now that we know what eluent we're going to use to elute the column, we need to find the right column dimension. And the column dimension depends on a lot of different factors. One factor is how much material you have. A second factor is how many materials are around. If it's a very difficult separation, you'll want to use a bigger column so you can resolve better. You'll use more silica gel in a longer column. If really the compound is pretty clean, you can get away with a much smaller column. So in this case, if you look again at that TLC plate, what you can see is there's only one visible spot. That spot was UV active, so I circled it with pencil, and it's also staining with phosphomolybdic acid. So it looks like it's a pretty pure material already, and so the column is really just going to be touching up its purity. So we don't need a super large column. One way to get an estimate of the column dimension is to take the compound in a round bottom flask and to look at the width that that puddle makes in the bottom of the round bottom flask. That width is a good estimate of the dimension of the column that you'll want to pick. So I've picked a column that has a very similar width to that width of that puddle. That's just a rough estimate. If the compound is very impure and has lots of impurities, you might want to pick a wider column that will contain more silica gel. We could probably, with this compound, get away with a narrower column because the compound is pretty pure. The reason why the width of the column matters so much is that you want to load the compound in a very thin layer. So we're going to fill this column with silica gel, equilibrate it, and then we're going to load the compound on the top of it that's to be purified. And we want that layer on top to be a thin layer. And when I say a thin layer, that could be anywhere between a millimeter layer if the compound is very impure and we have to do lots of separation. If the compound is quite pure, you can get away with a thicker layer of compound. It's going to be starting over a wider range, and then as it progresses down, there's less to be purified away. So really the rule of thumb is between a millimeter and a centimeter of depth on top of the silica gel is a good amount of compound to load in a column, although you have to keep in mind those variables I just mentioned, how pure the compound is. This is a pretty pure compound, so we're going to use a relatively short column of silica gel and a relatively narrow column to purify it. So this is the column that we're going to use. The next thing we're going to do is we're going to have to equilibrate this column with the solvent that we just discovered using the TLC method. So we know that we need a 1% solution of ethyl acetate in hexane. So that's what I'm going to do right now. I've got a jar here that contains silica gel, and I'm simply going to fill the... so I'm just going to pour in dry silica gel first, and if you can see, I'm going to probably put in, I don't know, between 5 and 7 inches of silica gel. It's just approximate. I'm not measuring anything out here. So this is the dry silica gel. This is the medium on which we're going to purify the compound. You certainly don't want to load the compound until the column is fully equilibrated with solvent that has the right polarity. So that's what we're gonna do next. So I have a liter of that solvent mixed up here, which is kind of a lot. Usually I would make up a little bit less. And so I'm going to just pour some solvent on top of the dry silica gel. Enough solvent that I think it could easily wet the material that's in that column. And I'm going to let it sit there for a second while I get an Erlenmeyer flask. I'm going to put the Erlenmeyer flask underneath the column, and now I'm going to actually do the equilibration. So in order to do the equilibration, you take the funnel off the top and you find a rubber stopper that won't sink into the top of the column. So I'm just going to put the rubber stopper in the top. I'm going to make sure the valve at the bottom of the column is open, and I'm going to carefully grab the column using one hand to hold the stopcock and the fragile pointed end, and hold the stopper in with the other hand, and I'm going to shake the column. And what I'm trying to do is I'm trying to wet all the silica gel in there until it's in a slurry, being very careful not to bump the ends of the column against the hood. This is where columns often get broken, is by people not being careful about especially the pointed end of the column. So now you can see that all the silica gel is in a slurry. There's no more dry white powder. Then you put this thing back into the ring stand and you position the Erlenmeyer flask under it so that the solvent drips into the Erlenmeyer flask. At this stage, I'm going to put a clamp in position to support the column. So you want the clamp at the bottom not to be super tight. It's just to keep the column from swinging side to side. And then you want to adjust the height of the column to the height of the tube that you're going to use to collect the fractions. So it's good to do this before you've completed your equilibration. So I've lowered the column. This is the tube size I'm going to use. And what I want is I want the tip of the column to be below the edge of that tube so that it holds it up in place. And I want it to be easy to move those tubes in and out because we're going to collect multiple fractions. So I'm adjusting the height, trying to get it just so the fraction tubes will lean up against the column but not fall down. So I'm just adjusting it now. That's a pretty good height. And notice this bottom clamp is not super tight. And then I'm going to try to make the column as level as possible. So I'm looking at it from all angles to try to get it fairly level. Meaning going straight up and down, not angled. Okay, so now we're in pretty good shape. The column has solvent on it, has not been packed tightly. The silica gel is equilibrating as we speak. And now what we're going to do is what we call pack the column. This is the part where the flash part comes in. So we're actually going to use air to drive the solvent through the silica gel. Okay? And so when you're in your hoods, what you're going to do is you're going to adjust the airflow so that there's some air coming through the glass stopper that fits in the top of the column. And then you're going to use your hand just to pressure the solvent and force it through the column. So I'm just using my hand to hold it on the top, and you can see that the solvent is moving out of the column relatively rapidly. And you can also see probably that this column is packing down. Okay, it's going to pack down to a certain height and then it's going to stop. It just stopped. And now what we're doing is we're just completing the equilibration and we're getting ready to load the compound onto the chromatography column. So we want to load the compound in the narrowest possible, the thinnest possible layer. So if we added the compound now with a bunch of solvent on the top of the silica, it would be diluted and we would be loading the compound in this huge volume. So that would not affect a very good separation, because the compound would be slowly working its way onto the silica gel, and that band would move down and all the impurities would be mixed with all the purified materials. Nothing would happen. So what we want to do is we want to do what we call draw down the column. So right now we're going to draw the solvent layer down just till it's even with the silica gel. So there's no solvent really on top of the silica gel. Now, another important corollary is you also don't want the column to go dry. So you're going to push the solvent level down until it's just at the layer of the top of the silica gel before you load. So I'm going to draw this down, just using air to force the solvent through the column. I'm going to draw this down until the solvent is just on top of the silica gel. Then I'm going to turn the stopcock at the bottom to keep it from going any further. Okay, so that's what we're doing. We're drawing down. Now I'm going to get my head level with it so I can see exactly when I need to stop it. Okay, so there we are. The solvent is just level with the silica gel, and now it's time to load the compound. So here's our vessel that contains the compound of interest. In order to load the compound, what we're going to do is we're going to use a long Pasteur pipette to put it in and directly on top of the silica gel. Now, the reason why we use a long Pasteur pipette is we don't want to interrupt the flat surface of the silica that's inside the column. So we're going to put the compound in, but we're going to use a long pipette to drop it in, touching the wall of the column so that it runs down gently and doesn't interrupt the surface. So here I go. I'm going to pick up this vessel. I'm going to pull some of this crude material into my pipette, and I'm going to put the pipette just above the layer of silica gel, and I'm going to slowly load it, trying not to make big divots in the surface of the silica gel, trying to preserve that flat surface that results from packing as best I can. Okay, and you can maybe see there's a little layer of the crude material building up there. And you just load the crude material right on top. And you can see that, well, maybe you can't see, the layer of compound here is between 1 millimeter and 1 centimeter. That's okay for a compound that's already moderately pure. That's why this column width was is a good choice, using that method I showed you before. So I've loaded the compound. There's still probably a lot of that compound in this round bottom flask. So I'm going to get a little bit of the running solvent, and I'm just going to rinse out the flask. I'm going to swirl it around, and while it's settling, I'm going to open the column and I'm going to draw it down again. So this time now, instead of pushing solvent onto the silica, I'm actually loading the sample onto the silica. And again, I want to stop it when the surface of the silica has just been exposed. Okay, so the compound is now loaded into the silica gel, so that top layer is actually the compound, not solvent. And now I'm going to load this rinse to try to transfer as much as possible to the column. So I'm loading the rinse. Get the last little bit. You want to get the highest yield possible. Most of what I just loaded is solvent, not compound, so I'm going to draw it down again and push the compound of interest a little deeper into the silica gel. So I'm going to open this stopcock again, and I'm just going to gently push until I just barely expose the surface of the silica gel. I'm going to do that process one more time, this time using just pure running solvent. This pushes the layer of compound about a centimeter or so into the silica gel, so that when I add bulk solvent, it doesn't dilute the compound and have the effect of loading it over a long period of time. The compound is being loaded in a narrow band on the column. So I've just put about a half a centimeter of solvent. I'm going to do another pipette full. And notice how I'm running it down the wall so I don't disrupt the surface of the silica gel any more than I have to. Okay, so then I'm going to draw it down again. This is going to force the compound a little deeper yet into the silica gel. Okay, so if you can see what's going on here, the column has one color, then you see where the compound is, and then there's a light layer on top where I've forced the compound onto the column. So the compound of interest is in this sort of off-colored band. We won't always be able to see it as we run the column, but while it's so concentrated, we can see where it is. The next thing I'm going to do is, now that the compound is safe from dilution, when I add more solvent, I'm going to fill this up and I'm actually going to elute some fractions. So that's what I'm going to do now. Notice how I'm running the solvent down the wall, again, to keep from interrupting the surface of the silica. The best way to do this is to use a pipette to load, I don't know, an inch, 3 or 4 centimeters of solvent, and then you can carefully pour down the walls. And so I'm going to do this while you have a close look. This is a good time to have a close look. This is kind of a delicate part of the operation. So I'm using a pipette to avoid making big divots in the surface of the silica. And I've added, I don't know, 2 centimeters worth now. I'll add a couple more pipettes and then I'll show you how to run it down the walls. And hopefully not stir up that compound that's loaded onto the gel. Okay, so if I use care, I can probably do that part now. The way you do this is you take the solvent that you're using, and it's best to use an Erlenmeyer to reduce evaporation. And using 2 hands, very gently pour the solvent down the walls so that it doesn't have a lot of force when it hits the surface. And you can see that it doesn't stir up the surface of the silica gel. It rinses the walls, but it doesn't stir up the surface. And once there's a big column, you can pour kind of at will. So I'm filling up this reservoir with the running solvent. The compound is loaded. It's not being diluted because there's that layer of silica gel on top of it. And now we're ready to actually elute the column. When it's time to elute the column, what you're going to do is you're going to find, you'll have a glass adapter that will match the top of your column, and you'll probably have a plastic clip to hold it on, and you'll want to figure out where that is. And now it's time to start doing the elution. So I'm going to put a clean Erlenmeyer under there, and I'm going to clamp the top and open this up, and then I'm gently going to turn the air on. And while I'm watching it, I'm going to try to see the rate that the column is eluting. You want somewhere between a rapid dripping and a solid stream. So if you look closely at the rate, it's somewhere between a column and a stream of solvent coming out. That's pretty good for a medium-sized column. I'm not collecting this fraction because I know that the compound of interest is way up here, but I'm also not going to wait too long because it's going to start coming out before too long, and I want to be able to capture it in a fraction. So I'm starting to collect fractions now. Make sure that you have a tube rack available, because as the fractions fill, you're going to switch it out for a fresh tube and you're going to start a row of fractions. I'm going to stop talking now while the column is eluting, and I'm going to collect a bunch of fractions and then we'll analyze them. Okay, so I've now taken a complete row of fractions, and it seems like this is a good time to go ahead and figure out whether the compound is in that first row of fractions. So I'm going to turn the air off to the column, and I'm going to go ahead and analyze these fractions by thin layer chromatography. So I'm going to stop talking now, and what I'm going to do is I'm going to make a TLC plate that has, let's see, there are 16 fractions here, so I'm going to make a TLC plate that has 8 dots, and I'm going to take every other fraction. Right now I'm just identifying if the compound is here and about where it is. So that's what I'm going to do. I'm going to make an 8 lane TLC and go ahead and run it up the plate. So I'm going to stop talking while I do that. Perfect. 8. Okay, so after I ran the TLC of the first 16 fractions, this was the result. The bottom spots on this TLC plate were all UV active. That's the compound of interest. We know it to be UV active. What we couldn't see under the UV light were the compounds that were up here. And what you can see is those nonpolar compounds came out relatively fast, and the more polar compounds came out a little bit later. But we can see that there are some mixed fractions here. So the first fraction, there's nothing. The first fraction I recorded, which is fraction 2, there's nothing in it. It looks like fraction number 4 has only the less polar compound in it, so we can discard that one. It looks like fraction number 6 has a lot of the compound of interest and just a little bit of the compound we're not interested in up there at the top. But by fraction 8, there's almost none of that undesired material. So we have a couple of options here. One, we could take another TLC where we look at every single fraction and decide exactly which fractions we want to keep and which fractions we want to save for later purification. Or we could just say, cut our losses and say, let's take fraction 7 and forward and assume that and be able to tolerate that little bit of impurity that's in the top. In this particular reaction, I know what that impurity is and it's not going to affect the next reaction. So I think I'm going to take fraction 7 and beyond, because 2 had nothing, 4 only had the impurity, fraction 6 had a lot of the desired compound and a little bit of the undesired material in the top there. I think I'll take from 6 forward rather than 7. I'll take from 6 forward. Another thing you can notice by this, fraction 16, which is represented by this last dot, still has compound in it, the desired compound. So what that means is we need to continue to run this column just a little bit longer. So we need to push out a few more fractions. So I'm going to push out 8 more fractions and then check them by TLC to see which ones you need to collect.